So thanks so much, everybody, for joining us for today's session. I'm Adam Scarzafava, AVP for Marketing and Communications at Edge. Today's webinar, we're going to dive pretty deep into unlocking the power of the cloud for scientific research, real-world use cases, and technologies for repeatable solutions. We're excited to have a few research leaders and experts from the Google Cloud organization here with us today to really dive into how some institutions out there are really making the most of the cloud to power their research efforts. Before we get into that, I'd like to just give a bit of an introduction to Edge and why we're bringing this session together in the first place, for those who might not know us as well. Edge is a nonprofit member-based research and education network and a technology consortium. We were founded by the New Jersey President's Council for Higher Education. Back around the turn of the century, the presidents of the higher ed institutions in New Jersey got together and came to the realization, essentially, that the internet wasn't going anywhere, and they needed to build themselves some capabilities to really excel in that digital world. We think that was a very wise decision, and Edge was formed kind of from that idea. We've grown over the years to serve not only the higher education space and not only kind of the everyday student life, educational aspects of education, but research as well, very, very deeply, as well as you can see, a number of other types of organization, types of institutions that really serve a public mission as well. So really any sort of organization or institution that has a public mission, receives public funding, or conducts educational activities, Edge is here to serve those organizations and help them excel through the use of technology. But really the core of what we do, the heritage of what we do, is in higher education and in supporting research. What we were initially formed to do was to build a network around the state of New Jersey, and that's EdgeNet. We still own and operate that network. Probably 99% of the higher ed institutions in New Jersey connect to Edge to get their internet connectivity. And that network is growing regionally as well. We've recently added institutions in the state of New York and in Pennsylvania to that network, and it continues to expand. That network also powers Edge Discovery. Edge Discovery is a technology-based research and discovery framework, and we're able to work with our members to do lots of innovative things on the network to support research, whether that's peering with other research institutions, internet to cloud frameworks that institutions need to connect to effectively conduct their research. We really try and build out those supports, and not only on the technology side, but on the leadership, guidance, grant support side as well. So Edge Discovery really kind of covers the gamut as far as backing up our research institutions that are in the consortium. Edge Market is our strategic and informed consortium procurement arm. Edge offers a number of services as a nonprofit, but we're not everything to everyone. And in those cases, we know that institutions need quick, effective routes to procure the technologies and services that they need. And so we formed Edge Market to do just that. And Edge Market is now a bona fide nationwide cooperative pricing system. We also host events, networking, and community building, just like what we're doing here right now online via webinar. We also host in-person events. Farouk Garamani is on the session here. Edge's AVP for Research, Innovation, and Sponsored Programs. Recently led in partnership with Princeton and a few other organizations an in-person research workshop, really getting hands-on with some research tools that the community uses effectively. And that was very well attended and a great session for those that were there. So we do those kinds of things. We do annual conferences. So we really try and bring the community together to build skills and share knowledge. And then, as I mentioned, thought leadership and solution development. We offer some services ourselves as a nonprofit. Digital transformation support, cybersecurity, privacy, and compliance is so important right now, both from a financial perspective, as well as protecting things like the IP that comes out of research. Cloud strategy, one of the things we're talking about here today. And then digital teaching and learning, where lots of institutions have challenges really moving at scale into the online digital learning modality. We're there to help them do that, help train faculty, help train students, So Edge really provides a multifaceted organization in the support of technology across the higher ed institution, growing out of that heritage of networking and research. And so I think that brings us to a good point to hand it over to our friends over at Google to really get into the meat of today's session and talk a bit more about how the cloud can help to power research. And a quick note as we do that, Edge's network is peered out to where Google lives in the cloud, and via Edge Market, we do have some vehicles that are available to accelerate the procurement of research-based solutions in the Google Cloud. So lots of support and lots of good connections between Edge and the Google Cloud organization. And we're excited to really dig into the details here of what Google Cloud is up to out in the cloud for research. So with that, I will stop sharing my screen and I'll cede the floor to our friends at Google.
Great, Adam, thank you so much. My name is Matt Kainoff. I am Director of Public Sector here at Google Cloud, supporting the state of New Jersey, both state government and education. So I support higher ed in the state of Delaware as well as New Jersey. Before I hand it off in a moment to my colleagues on the engineering team, I have Volker and I have Keith Binder that support research for Google Cloud and Google Public Sector across the nation. I just want to say a few words. I want to thank you for spending time with us and your interest in learning more about Google and our efforts to partner with the higher ed community, the research community specifically, and how we can support your efforts. For me, it's about partnering with the institutions in the state of New Jersey, whether the large ones with Princeton and Rutgers and NJIT and Rowan, or the tier twos, right? And with and through NJ Edge is to offer you that burstability to help support and advance your research in Google's cloud and take advantage of some of the technology that we have out through AI and ML models that really can help advance your research. If you find that you don't have the physical support on campus, whether those are physical resources or IT resources, it's partnering with those folks and you to help you burst when you need it most, whether you're working on a cyclical grant where you have 3 months or 6 months or a year where you have intense research. And then you need to scale back when that grant ends or that program ends. It's offering you that partnership and that scalability through our friends at NJ Edge. So my goal in taking over higher education, I've been at Google now 3.5 years. I've had higher ed all of 2 months, is really to support you, support your efforts and support the efforts of your peer to help you hit your goals, the desired outcomes, and most importantly, advance your research using the power of Google's giant network and the types of services, supports, and the breadth and depth of technology and the platform that we have, whether we're taking advantage of these new Gen AI models, the machine learning models, or just standard compute, storage, and HPC clusters that we have. So with that, I'll hand over to both Keith and Volker. They'll be running the majority of today's webinar. Our goal is really at the end of this is answer any questions that you may have and then schedule follow-ups with you directly, whether that's with our friends Faru and Adam at NJ Edge or just directly. I live local in Bucks County in PA, so getting out to see you is very easy for me. Thank you very much.
Thanks, Matt. Hello, everyone. I'm Keith Binder. I'm a customer engineering manager here at Google Cloud. And my mandate is to focus on the higher education and research community. And with me is Volker Eyrich, who is one of my leads in the research under the practice area. And what we want to do today is share our experience in working with the higher education community as to how best to consume cloud to accelerate your scientific discovery. Next slide. So to that end, we want to go to the beginning and discuss how Google Cloud and research got started, and in some respects are a perfect marriage. We then want to discuss what we've seen throughout our endeavors with the research community and describe some of the trends that I believe a lot of you may be seeing as you accomplish your research. And then we'll talk about how you can combine Google Cloud with your research objectives to achieve time to answer, faster than you may be able to do with your current environment, and how you can achieve that using some of the repeatable solutions that we've seen other customers pursue. And lastly, we'll get into the nuts and bolts and talk about some of the tech that underline some of those solutions. Next slide. So let's rewind and talk about how Google got started, right? For those who aren't aware, Google originated out of academia. It started as a research project at Stanford. Sergey and Larry wanted to figure out how to categorize all the data that was out there. And they utilized the resources at Stanford and other institutions to create Google. And the reason I bring that up is Google originated as a research project, but it didn't stop there. The founders believed that research was a key vehicle in progressing not only what Google could do, but what the scientific community could do. And they fostered an internal division early on called Google Research, whose core mission is to explore new ideas and bring those ideas to market. And so if you look over the last 20 or so years, Google Research has released various papers such as Google File System and Google MapReduce. Both technologies were incubated within Google proper, yet we expose them to the open source community into a technology you may all know as the Hadoop system. And that has continued throughout when you look at technologies such as Dremel and PubSub and TensorFlow. We don't keep those technologies tight to our chest, right? We test them internally, we figure out uses for them, we release it to the open source to let them iterate on them. Yet we know that some of these technologies can be very complex. So for some of these open source technologies, we take that open source mindshare and expose it to the end users as native services within Google Cloud. And you can see that with technologies such as BigQuery and PubSub, as well as our machine learning environment. Next slide. And to expand upon machine learning, one of the topics that everyone has on their mind is this notion of large language models. And I think it's important to understand that Google has been at the forefront of large language models, generative AI, since the beginning. For those who may not be aware, if you look at ChatGPT, the T in GPT stands for transformer, which coincidentally is the underlying technology that Google invented back in 2017, right? Suffice to say, we have been iterating on large language models. We have recently exposed a lot of those models to the public, but it's also important to realize that we've given the end user exposure to a lot of these large language models behind the scenes without them being privy to the notion of generative AI or large language models. If you've ever used Gmail, you may have started typing an email and all of a sudden Gmail knows the next couple words that you want to say. Behind the scenes, that was a large language model. And as you can see, we've done over 3,000, we have 3,000 researchers and 7,000 publications within that space. Next slide. And this collaboration of research and Google just doesn't reside in Google proper. Google is part of Alphabet. We have a lot of subsidiary companies underneath the Alphabet umbrella, but each one of those subsidiary companies has research at its core, just like Google had research at its core. So if you look at Verily and what they're trying to do to improve the quality of life, or Calico with longevity research, each one of them not only has research divisions, but they want to expose that research that they're incubating to a wider audience, right? And you can all see that, whether it's discussions such as what we're having today, or some of the relationships that we've forged with agencies such as the NSF and the NIH, as well as teaching opportunities that we provide with some of our professional development curriculum. Next slide. So let's chat about what we've observed as far as the latest trends within the scientific research industry. As we talk to customers, we tend to see these 5 themes arise in some shape or form, right? The first theme being data. I think it's fair to say that data is not decreasing in size, right? It's only getting exponentially bigger. And because data is getting exponentially bigger, you're going to need the requisite horsepower to do the number crunching against that data, which leads into the second trend of high performance computing. Back in the day, high performance computing tended to be a niche area that a certain segment of research community would tap into. But what we've seen, especially over the last 5 years, is all forms of research, right? Whether it's weather forecasting or genomics, any of the sciences, are taking advantage of the scale that a high performance computing environment can provide in order to get outputs from that data. The third trend we've seen is this acceleration towards artificial intelligence and machine learning. As I mentioned earlier, large language models are the it thing. Training those large language models requires a lot of horsepower. They typically require an environment like a high performance computing environment. But the research community at large wants to augment what they're doing with their research with some of the AI and ML technologies that are out there. And research is only as good as someone who can validate the findings. So reproducibility has always been a big trend, but I think it's top of mind now when you look at the NIH's FAIR principles, right? Research has to be findable, accessible, interoperable, and reusable. And then lastly, we've seen that a lot of these research endeavors that are going on are no longer isolated to a single PI or group of researchers, but they expand across multiple institutions and multiple PIs and multiple groups of researchers, which requires that cross-institutional collaboration. Next slide. So what are we doing, right? What is Google Cloud doing to change the way you as a research community are conducting your research? If you look at how researchers typically would approach a research challenge, they would have to, in some respects, bring the data to the compute, right? If there was some data set that you wanted to do some analysis on, You either, spun up an FTP server, downloaded that data, copied it to your local on-prem systems, and executed your findings. We changed that in the cloud environment. With the cloud, you can bring the requisite compute towards the data. So no longer do you have multiple copies of a known data set floating around in an institution, not only occupying space with the underlying storage platform, but also making it challenging to share that data with others. And because research is getting bigger, the problems are becoming bigger, the data is becoming bigger, it's not so trivial to share multiple terabytes, even petabytes of data. With cloud, you can simply add a user's credential to a data set and share that multi-petabyte data set in a second. And then lastly, compliance always rears its head with research endeavors. It's typically very painful to get all the security fundamentals implemented, both on a central IT side and for a researcher. With the cloud, we try to alleviate some of that and automate some of the security implications you may have had to do manually in the past. Next slide. So why should you look at Google Cloud for research? Well, there's 4 areas where we think it aligns nicely with what you want to do. The first one is it's simple and intuitive, right? The nice thing about cloud is it's ephemeral. You can scale the cloud up when your research problem requires it. And guess what? You can scale it down automatically when you no longer need it. This notion of idle resource doesn't need to apply when you utilize the cloud. You can also use the tools that you know and love and seamlessly transfer them into a cloud environment. At Google, we are very committed to the open source community, and we allow you to utilize the tools not only on-prem, but in our cloud as well. And then from an economic perspective, we're changing the way you consume cloud from a traditional quote unquote OpEx model into a CapEx model that can provide some predictability. We also have a large footprint of fiber optic cables across the globe, which allows you to seamlessly not only share your data, but the users who are accessing your data can access it with minimal latency. And it also affords you the ability to put your data sets out there to the public at large so they can access them at will. And based upon some of the research endeavors that we have done at Google Research, right, we are releasing those models to the research community for you all to consume and apply against your research. So if you look at some of our models around LLMs, right, models such as PaLM or MedPaLM in the future, those will all be available to you as a community to take advantage of those pre-trained models to use against your research. And then lastly, everything within Google Cloud is encrypted. It's encrypted at rest and encrypted at transit. So you don't have to think about, is my data secure? That zero trust is natively built in, so you don't have to worry about it. Next slide. And just to expand upon that, we allow you to quickly iterate and experiment without cost overruns. We have some foundational blueprints in our open source community called RadLab that are defined environments that you can spin up, such as a bioinformatics platform. And you don't have to worry about what's the compute stack, what's the network stack, what's the storage stack, what are the tools. Those are all encompassed within that blueprint. And if you combine that with our subscription agreement, you can have flexible resource provisioning without worrying about any cost overruns, as it's a deterministic cost for a defined period. As I mentioned earlier, we make it very easy to collaborate with users and share that data. We have technologies such as our public datasets program and analytics hub, which gives you insight into the various data sets. And then lastly, technologies, as I mentioned, such as RadLab will give you that pre-configured blueprint, not only with the entire stack that you required in the cloud, but also with some built-in security. And then you can orchestrate the security across all your projects with technologies such as Security Command Center. Next slide. And to give you an example of some of the power of RadLab, we had a team that worked with Battelle Neon, who had a challenge in that they were creating these data sets that frankly were not being consumed. And when they did some investigation on why they weren't being consumed, what they found is the public didn't know how to interact with those data sets. So we worked with Battelle Neon, and they formed what we call a RadLab module. So an end user could use the open source RadLab toolkit, spin up the Battelle Neon module, and within that module, we would provide an example Jupyter notebook pre-configured with the data sets that Neon provided to the public, as well as example queries. So the end user could see how to interact with that data set. And they saw the usage increase dramatically by providing those examples. Next slide. And with Natural Resources Canada, they decided to take advantage of our Earth Engine platform, which has a vast amount of data sets. And they augmented the data sets with Earth Engine to create a platform for their end user to understand, in this context, the foliage in real time. And not only did they augment that data set, they contributed that data set back to the public in regards to our public data set program. Next slide. And we realize that cloud can be sometimes perceived as complex. There's a lot of services are out there. And we know as a researcher, you just want to get your research done. So to that end, we are coming out with a dedicated instructor-led course entitled Cloud Fundamentals for Researchers, where we're going to provide you an introductory level training on the tools that you need to accomplish your research endeavors. So stay tuned for that. Next slide, please. And so in summary, we want you all to utilize cloud to advance science, and not only advance science, but make that science open, easy, and innovative. So with cloud, with Google Cloud, we provide the open source tools and templates. You're not locked in. You can choose to run your research on Google Cloud. You can also choose to take it away from Google Cloud, right? That's your choice. We provide that intelligence layer. We have the analytics solutions that allows you to make insights into your research. We allow you to not only make those insights, but share those insights, given the collaboration capabilities of the cloud. And then lastly, it's a secure cloud. Your data is your data. You're always in control of that data, and it's always encrypted. And from an environmental perspective, all of our data centers run on 100% renewable technology, so you can rest assured that it'll be a clean cloud. Next slide. And with that, I want to turn it over to Volker.
Unmuting helps. But any questions on the content that Keith provided, though, before I dive into some of the details around compute, storage, analytics, and the like? Did anybody have questions about how cloud could be used for scientific research?
I don't see anything yet coming across, Volker, but I'll keep an eye on it, and if anything does, I'll let you know.
Sounds good, Adam. It's just there's a little bit of a shift in terms of content, so I wanted to make sure that we at least give the audience the opportunity. So I'll talk a little bit about advanced computing in Google Cloud. I'm a researcher by training. I've used Google Cloud quite extensively for scientific research. And so I've experienced firsthand how useful cloud infrastructure can be to conduct especially compute-intensive or computational-intensive research, also data-intensive research. At a high level, what I think really positions Google Cloud very well for research challenges is we have developed, deployed, and expand and continue to expand a very powerful set of infrastructure, right? As you would expect, there's highly capable, highly performant compute network storage offerings that the cloud provides to you. GPUs are critical to a lot of the AI/ML workflows these days. I'm sure you've come across that. We offer a full complement of this, and we'll see that in a little bit. And we've really tried to accelerate as much as possible the deployment of new technologies into cloud as soon as possible, ideally first. So that's oftentimes a place where you can use the latest and greatest technologies first. An example is GPUs. Google Cloud has a very strong story on GPUs. We've been the leader in that, oftentimes introduced the latest NVIDIA offerings, for example, into cloud very, very early on. Recent example is L4s just came out, H100s just came out. Those are extremely capable systems, and anybody doing AI/ML, especially on large data sets, should really consider looking into the cloud offerings to see how they could potentially accelerate their research work substantially. We've also focused explicitly on high-performance computing, and scientific computing and high-performance computing is sometimes used interchangeably. When we say high performance, we mean high performance, right? That is ultra-fast processor, ultra-fast networks, and also, and I think this is important to remind people of who may work in fields like computational physics, computational chemistry, we can run very well tightly coupled jobs, for example, in Google Cloud at scale. So the likes of molecular dynamics, for example, can be run very, very well in Google Cloud, for example. We have multiple access modalities. You can do that using the traditional approach, maybe your own, using just the raw VMs that we provide as the infrastructure as a service offering, or you can deploy via something called Cloud HPC Toolkit, which has gotten a lot of traction over the last couple of months. You can deploy in a more or less automated fashion batch schedulers, storage solutions, and the like. You can use GKE if you're familiar with the container ecosystem. You can use Batch, which is a new service we've been offering for about a year now. Batch is basically a fully managed batch scheduler where you don't even need to worry about managing any sort of infrastructure. And all of those come together in Google Cloud when you need them for the purpose that you need them for, right? So you're not, and Keith alluded to this earlier, you're not making this long-term plan about what would I need now in 3 months and 6 months. You use what you need when you need it. That could be large-scale compute, that could be large-scale data, could be GPUs for training an initial model. So you have that flexibility. Spend a lot of time, of course, on machine learning. Google and Keith alluded to this earlier as well. We've been a leader in AI ML for a long period of time, adopted this way early in the 2000s, and have a very comprehensive platform for all things AI ML, including the operational aspects of it, right? You have to publish models and get them to run at scale potentially so that other people can use them. We also have a substantial effort going on currently in quantum computing. The quantum computer itself is, of course, still a very experimental technology, let's put it that way, not just ours, but any quantum computer. What a lot of people do is algorithmic development for quantum computers, making sure that when those systems become more generally available, you have algorithms that can actually take advantage of them. And developing quantum circuits is not exactly easy. It's quite a paradigm shift from what we've done previously with standard binary math, right? But what people use Google Cloud for quite extensively is quantum circuit simulation to get a head start on what those algorithms could look like. With the hope or the projection that in a couple of years' time, you can run on the actual quantum systems that we will offer. So moving on from that, let's focus a little bit more on some of the high-performance computing aspects. Why high-performance computing? I think for some of you who may work in, like I said, computational physics or computational chemistry, biology, that may be somewhat obvious, but just to highlight one example where this had pretty broad-ranging implications. It was a study carried out at Harvard. They're developing a system called Virtual Flow, which very much facilitates, automates what is called virtual screening, where you test a large number of chemical compounds against the receptor or target to see what their effect could be. That could provide starting points for drug discovery. You develop what is called a lead, or a hit first and then a lead. So they carried out a really large study, 16 proteins, 33 target sites, 35 billion docking instances. A lot of compute went into this. They were able to do this in 3 weeks, which is pretty amazing. Not everybody needs to run a calculation at scale or at that scale every day. We understand that. But what I think is important to remember is that when you need that sort of computational capability, you can get it. They provisioned all of this on GCP. It's extremely quick. It's extremely straightforward, right? You've taken or made a big effort to automate this as much as possible for you so that you can run this at scale. So things like that are now within reach. And they're probably more attainable in cloud than any place else. A number of on-prem systems are fairly capable and fairly substantial, obviously. But being able to quickly corral a large number of resources to carry out studies like that can be really game-changing for research. So what makes HPC on Google Cloud? What are the characteristics? How does it distinguish itself? Some of it Keith already referred to. I mentioned some of those things earlier. We won't go through all of it, but I think what's key is it's performant, it's affordable. There's a number of costing models that can really put this within reach, or large-scale calculations within reach of just about any researcher. We very much focused on ease of use and compatibility. Google has a very strong story on open source. Keith mentioned this earlier, and we continued this, of course, with HPC, which is oftentimes driven by open source technology. So we made sure that you can interoperate with systems that you may have used in the past. There's no major learning curve, that you have to go through or deal with before you can actually run some Google Cloud. A lot of partners support GCP for high performance computing. We had a very strong relationship, to just give one example, with SCADMD, who maintain or make available Slurm, the resource manager. And together with partners, we offer really a very, very strong and compelling product in our opinion. And it brings all of Google, or all of the technologies that Google develops and relies on internally to use, so you can take advantage of them as well. So we will not go through every single topic on this slide, meaning compute, storage, network, and HPC software, simply because that's a fairly detailed discussion and would take quite a bit of time. Just know that we have an extremely capable backplane, control plane, if you want to call that. The VMs that you try to provision in GCP boot literally in seconds. You can have a VM up and running in 15 seconds. And the reason why I wanted to mention this, if you have large-scale computational problems that you want to address, having that sort of scalable control plane is extremely important, because if you need to provision 100,000 cores to run a calculation, you don't want to take that. That to take an hour. You want that to want to do that in minutes. So be able to do that. Our network is unparalleled, I think. Internally, we have an exceptionally capable network. Keith mentioned we also have a very global footprint. So collaboration is very much easy, and collaboration is part and parcel these days in research, of course. We offer a number of different storage options, and here I'm speaking specifically to high performance storage. We'll get to that in a minute. And we mentioned some of the tooling that we already offer and that partners offer on Google Cloud. So this is not something we started yesterday, right? We have a long history of doing HPC on Google Cloud. Goes back to probably about 2018, 2019 is when we really kicked off this effort. Since then, we've brought onto the platform a number of really strong innovations. Again, we can't talk through all of them, but bottom left, for example, we were the first ones to put NVIDIA T4s into the cloud. Very capable and cost-efficient inference engine, for example. A lot of people use that to drive everyday machine learning. 2020, we pushed out A100s as the first ones in cloud. Extremely capable systems, currently available in up to 16 GPUs per instance configuration. And we have enabled a number of HPC-focused offerings, for example, higher bandwidth, higher MTUs, for example. And rushing through this, I understand, we have spent a lot of time, and you see that at the bottom, at the top right here. You see the HPC Toolkit that is internally developed, but is open source. We've spent a lot of time. There's a substantial team behind the HPC Toolkit effort to make sure that you have a very smooth on-ramp to cloud. And you can reuse some of the knowledge that you may have gained using on-prem systems, but you also see new offerings that just aren't available on-prem. So we talked about GPUs a little bit, and not to dive too deep into this, but we have a very complete set of GPU offerings currently in GCP. We started with K80s way back in 2017, I think. And the slide doesn't show that we are deploying H100s in the near term. L4s just came out from NVIDIA. They're already available in the cloud in preview. So a lot of those technologies really are critical to state-of-the-art AI and ML. So we're not showing this just, to show you what it is that, you necessarily can provision on GCP, but those really can make the difference between training a model at large scale and getting exceptional results from it, or having to really trim down your model because you don't have the resources to train it properly or train it in a reasonable amount of time. What we didn't show, because it is somewhat of a complex topic, is all the CPU offerings. As you can imagine, CPU offerings there's lots of them. There's AMD, there's Intel. We offer just about anything that is out there. In fact, just came out with what are called C3 instances. So they're based on Intel Sapphire Rapids. Extremely capable platform. Comes along with 200 gigabit networking, which is very capable. So if you, as I mentioned earlier, run tightly coupled workloads, you can really benefit from that. The other thing that, and this is maybe more for the HPC crowd, they really try to address some of the challenges that people running HPC codes face every day. That could be bandwidth, it could be latency, it could be NUMA alignment, for example. The HPC technologies that we push out, in particular the latest instance types that we released, really speak explicitly to that. So you can get a very well-defined NUMA mapping that really represents underlying hardware. And that's what's oftentimes critical for running those really challenging codes at scale. So storage is oftentimes the hardest thing to get right, not just in cloud, but on-prem as well. We use lots of data. We use it all the time. It keeps growing. We need to, for example, when you train a large language model, you have to ingest a substantial amount of data, iterate over that data set multiple times. That's where you need a performance storage medium. And you may, depending on the use case, need multiple storage medium, right? What we currently offer, you see that on the left here, and I don't know whether you can see the mouse pointer, but on the left side, you see the Google Cloud native offerings. One is cloud storage, that is object storage or blob storage, as it's called sometimes. Near infinite capacity, so you can provision whatever it is that you need at the stage of the research that you're in. Very capable, very expandable, can deliver a serious amount of data in a sustained fashion. If you need more traditional storage, persistent disk or local SSD can fit that bill. So if you need something that is POSIX compliant, for example, allows you to run more traditional workflows, that's obviously available. If you need a shared file system, file store native offering, again, by Google Cloud, can really fit the bill here. It's available in multiple tiers, so depending on the performance requirements, you can pick the one that makes the most sense for you. What I think is important to point out, though, is that a number of partners offer industry standard, extremely capable systems on GCP, NetApp, Dell, DDN. DDN is very much focused on the high performance space. Spectrum Scale from IBM, formerly called GPFS, has been around for a good 20 years. It's almost like an industry standard. That is available in GCP. So if you had a use case that asked for highly performant storage for an HPC use case, we can certainly address that. On the very left, you see Intel Deos. Intel Deos is currently being used on a fair number of the supercomputers in the top 500 list. We've adopted this. We collaborate very closely with Intel, make that available as part of the HPC Toolkit currently, and down the road, this is going to be a first-party offering. This is a next-generation parallel file system that will really enable you to run at unprecedented scale. So if you have any questions about how this translates into, or how this relates to on-prem system, how that translates into enabling high performance computing on GCP, please let us know. We'd be happy to talk through that. Storage is a very complex topic, I get that. But at a high level, just know that there's Google native offerings, extremely capable. If you have a need for specialized storage media, you can address that potentially with partner offerings. So how do you actually use that? But we talk a lot about technology and what's available. There's a couple of ways to do it. One is spin up the raw infrastructure and install what you need and just use it. That's the DIY approach, basically. Mentioned the Cloud HPC Toolkit earlier. The Cloud HPC Toolkit basically automates the deployment of a complete HPC stack. And it's very much a hands-off approach. You write the description of what it is that you need, what you want for your particular use case. The HPC Toolkit will turn this into Terraform code or infrastructure as code, and then push this out. And you now have a fully functioning system. When you're done with that system, you no longer need it. You can just tear it down. It never existed. Doesn't incur cost anymore. Last but not least, and I mentioned this briefly earlier, Batch is a fully managed batch system where you provision nothing, you don't manage anything. All you do is, here's what I want to, you specify, here's what I want to run. Here's the type of resource I want to run this on. Please go run it, right? So if any of you have used a scheduler or batch scheduler and have written a job script and submitted that, Batch will basically do that for you, but there's no moving parts on your side, right? You just worry about running the job. So I'll go through those transitions real quick, just in the interest of time. The HPC Toolkit offers a number of Google native products, as well as those partner products that I mentioned earlier. You see that on the right. For those who have done HPC, you may recognize some of those technologies. SPAC, for example, is very popular these days because it allows you to automate and streamline installation of scientific software packages, compilers, actual applications, and the like. Again, would be happy to deep dive into this. You can also take a look yourself. If you look for the HPC Toolkit on GitHub, it will give you a very good sense of what the system supports currently. And just to give you an actual example, without showing you the blueprints, it's a couple of pages long, so it would be hard to show that here. But you can, and it's on the Cloud HPC Toolkit GitHub page. You can deploy, for example, a complete HPC system from beginning to end that lets you run GROMACS, so molecular dynamics code, complete with storage, complete with remote visualization. If you, for example, you've run your molecular dynamics simulation and you now want to visualize the trajectory of that particular complex target, whatever it is that you looked at, you can do that using the remote visualization capabilities that were deployed as part of that blueprint. So you can deploy very capable systems. This is not just to deploy toy systems. This is or the HPC Toolkit can deploy actual production systems. And then Batch, just to briefly take a look at that. As I mentioned earlier, fully managed. You basically don't have to do anything other than spell out what it is that you want to run and what you want to run it on. You can consume that either from the console, which is what you see on the right side here on the slide, or you can do that via the command line. You write a YAML file that specifies the job similar to what you would do when you write an batch script. Basically, submit it. It goes off, does its work, notifies you when it's done, and you can just collect the results at the end. Right? And again, those technologies would be happy to dive into if there's interest. Probably a little too tight to talk through, and in terms of time to talk through all of this, but just know that Batch supports not just single-threaded, high throughput computing type jobs. It also supports tightly coupled parallel jobs. So you can run the likes of GROMACS through Batch. It is not limited to smaller scale and more simplistic jobs. Just know that. Other than that, there's plenty more to discuss in terms of HPC-focused technologies. Be happy to take this up one-on-one, dive into the specific challenges that you have and see how Google Cloud HPC technologies could help solve those problems. Adam, why don't we stop here and leave a couple of minutes for questions? What do you think?
Yeah, we have just a couple of minutes left here. So I think first a question around support for researchers. So with so much sort of complexity and so many different tools that Google can make available, for the individual researcher, for the individual department, looking to kind of navigate these and figure out, what sort of infrastructure, what sort of tools are appropriate for their research, for their projects, what sort of support exists to help with that part of it?
Yeah, so we're always eager to help people understand what cloud technology may be appropriate for a particular use case. I mean, we went through a large stack of technologies, Adam, obviously, right? So I totally understand how this could be a little bit challenging to navigate, but just know that we're always happy to understand the use case together with the researcher, figure out what may or may not be a good fit in terms of technology, and then see how we can actually deploy this, make this work, and potentially fine-tune it as the needs, for example, evolve, or as we learn more about how that workflow works. Keith, anything you want to add to this in terms of support and how we generally do that?
No, I think you covered it.
So the short and sweet is reach out to us, let us know what challenges you're facing. We would be very happy to talk through that with you and figure out what makes good sense.
Great, thanks. And then on the technical side, for folks in the IT organization looking to work more closely with the research community and support research efforts, you mentioned a few trainings that are available. Where would we want to point people there for the IT side of the house, who's looking to learn more about high performance computing, get their hands a little more dirty, and figure out how they can better help the research community? Yeah,
so there are a number of resources out there. You can find them actually fairly easily on the HP or the website dedicated to HPC on Google Cloud's main page. We can also send you a couple of resources that make sense. Again, this being such a broad field, feel free to reach out to us and we can recommend specific tutorials or pieces of documentation that may make sense to you. To give you an example, some people coming more from an IT background or an HPC background have very specific questions about the capabilities of the hardware, for example, or the networking, etc. And we would be happy to go find that list of bookmarks, so to speak, that addresses those questions, or have a one-off discussion about particular capabilities of a service, if that makes sense, Adam.
Okay, great, thank you. So I think that's all we had at this point. Like I said, we've recorded the session, so we'll be sure to send it to everybody who was in attendance, as well as include the contact information for the folks that you heard from on this call, so that you can reach out if you have any questions or need any support. So thanks so much, Keith. Thanks, Volker. Matt, thanks for chiming in as well. I think this was a great, very informative session. We really appreciate the time you've spent with the Edge community here, and we hope to talk to you again soon.
Thanks, everybody.
Thanks, everybody.
Thanks, everyone. Have a good one.